In this video lecture, we're going to try and learn how to name organic compounds, and I've already told you that there are an unlimited number of different organic compounds, and they are classified into many different families of compounds, which are called homologous series. And each individual organic compound has a specific name. So there has to be a systematic method with which these compounds are named. So we will start off with by naming alkanes first. So as we've already discussed, alkanes contained only carbon and hydrogen atoms. They're probably the simplest of all organic compounds. So they only have carbon and hydrogen atoms, which means that they are hydrocarbons, and all of the bonds are single bonds. So all are single bonds. So that was what an alkane was. Now we will start off by naming straight chain molecules first. So, and what I mean by straight chain is, so a straight chain substance is where all the carbon atoms are lined up, or they are in a continuous row. So let's say I'll draw a few alkanes first. Let's say I have an alkane which has 3 carbon atoms, and this is supposed to be attached to 3 more hydrogen atoms because carbon makes 4 bonds. This one would be, it's already making 2 bonds. This would be attached to 2 hydrogen atoms, and this would be attached to 3. It's going to make 3 more bonds. Now this is one alkane. Now the basis on which we start off by naming these compounds is by we start counting the number of carbon atom. So our chain is named after the total number of carbon atoms, and which is the prefix. The prefix of the name. And what I mean by prefix is the starting part of the name of a particular name. It's based on the total number of carbon atoms. So it's named after named after the total number of carbon atoms in a particular molecule. So the first one, if a particular molecule has 1 carbon atom, just 1 carbon atom, its name would be starting off with the meth. So the prefix or the starting part of the name would be meth, and it would be followed by some other thing. But the starting part of the name would be the name would start off with meth. If a particular molecule has 2 carbon atoms, then its name would start off with eth, and it would be followed by something else. If it has 3 carbon atoms, the name would be followed by prop. That would be the prefix. It would be starting off with prop. If you have 4 carbon atoms, then your name would start off with but. And so on. This would be referred to as the counting in organic chemistry. So if you have 5 carbon atoms, your name would start off with pent. 6 carbon atoms would be hex. So the name starts off with hex. 7 carbon atoms would be hept. 8 would be 8 carbon atoms would be oct. You might have heard of octane, which is used as a petrol, and 9 carbon atoms would be non, and then you have 10, a molecule containing 10 carbon atoms. Its name is going to start off with dec. So it's not going to be limited to this, but you would have to remember this. You would have to remember, because all the organic molecules, the name would be indirectly based on the number of carbon atoms that they contain. So you must remember this. Whenever if a chain has 1 carbon atom, its name would start off with meth. If it has 2 carbon atom, its name would start off with eth. For example, the molecule that I drew over here, this particular molecule has how many carbon atoms? It has a total of 3 carbon atoms. So if you look at the counting, the name should start off with prop. So you must remember that no matter what the homologous is, if the carbon chain has a particular amount of carbon atoms, its name would start off with this. You can look up at this table and you can figure out what the name would start off with. Now when we are talking about alkanes, we already figured out what the name would start off with. But whenever you have a compound which is an alkane, the name for alkanes, for a particular alkane, if a particular compound is a part of this homologous series, its name would always ends with ane, which is ane. So for example, the compound that we were studying before, the initial name would start off with prop, because there were 3 carbon atoms in this particular molecule. So the initial name would start off with prop, and the suffix or the remaining name would be ane. So the name of this particular molecule would be propane. Similarly, we can do more examples. So it's pretty easy to name alkanes. We can do a few more examples. Let's say I have methane. Now generally the name is written together. Both parts are written together. I'm just putting spaces over there so that you can understand properly. So if I have methane, what that means is that this particular molecule is going to be having how many carbon atoms? It's supposed to have there's going to be 1 carbon atom, and this particular molecule would be since it's ending with ane, so this particular molecule would be an alkane. So if you have 1 carbon atom, this is supposed to make 4 bonds. So 4 single bonds would be made with 4 hydrogen atoms. And in an alkane, you can't make double bonds, so there would be 4 single bonds. So this particular molecule is a molecule of methane. We can do more examples. Let's say we have let's say we want to know what butane would look like. So let's say I'm again breaking up the name. Now what BUT stands for, if you look at this table, it stands for 4 carbon atoms. We can underline this. BUT stands for 4 carbon atoms. So this particular molecule is going to have 4 carbon atoms. So you can draw 4 carbon atoms. And we are talking about straight chains right now, so those 4 carbon atoms would all be lined up, and there would be, this carbon atom needs to make 4 bonds, so there would be 4 hydrogen atoms attached to it. So this is a molecule of butane, where but means that you have, this part means that you have 4 carbon atoms, whereas this part means that it's an alkane. Let's do one more example. Let's do an example of ethane. Let's keep the molecule size small at this point. Let's say we have ethane. Now I've written that together, but if you break it apart, it's the first part. The first part in this particular case stands for eth, and if you look at the table that I have drawn, eth means that it has two carbon atoms. So in this case, this particular part says that there are a total of two carbon atoms in this molecule, and the last part, which is ane, stands for an alkane. So it's an alkane having two carbon atoms. So you're going to have one carbon atom and two carbon atoms, and they would all be joined, and since it's an alkane, this carbon atom would be making three more bonds, and this carbon atom would also be making three more bonds. Now, naming other homologous series would be very similar to naming alkanes. The basic rules are exactly the same. So let's start off with alkenes now. So if we want to name an alkene, and let's revise first what an alkene was. So an alkene also only had carbon and hydrogen atoms, and it had this functional group in it as well. There was always at least one carbon double bond carbon present. There could be more than one. So this particular functional group was present in an alkene. So all alkenes contain this functional group. So we're going to start off by naming alkenes. The basic prefix is exactly the same. The prefix is based on the total number of carbon atoms in a molecule, and we are again talking about straight chain molecules. So it's based on the total number of carbon atoms. So you can look up at the table. If there's two carbon atoms, the name would start off with eth. If there were eth would mean two carbon atoms, etc. Prop would mean three carbon atoms. But would mean the molecule has four carbon atoms. So the prefix would be exactly the same, whereas in this case the suffix would change. The name would end with "ene". For alkanes, the name would end with "ene". So we can do one example first. Let's do one example. Let's say I have a molecule which has four carbon atoms. So if there are four carbon atoms, and since I'm doing this for alkenes, there must be a carbon double bond carbon present. So let's draw a carbon double bond carbon at any point and complete the bonds by putting hydrogen. So this one needs 4 bonds. So there would be 4 hydrogen atoms attached. This one needs just 1 bond. This also needs just 1 bond. This needs 3 bonds to complete the bonds. So you have now this is a molecule which has 4 carbon atoms, which means if I try to name this molecule, the name should start off with but. The reason it should start off with but is that it has 4 carbon atoms, and since it's an alkene, it should end with "ene". So but over here means that the molecule has 4 carbon atoms, whereas "ene" means that it's part of the alkene homologous series. Now there's one additional information that you have to add when you're writing a particular alkene, is that apart from the prefix and suffix, right in the center you would have to mention the position of the double bond. or the functional group, which is C double bond C. We need to mention where that C double bond C is located on this entire. This is the total carbon chain, so you would have to mention where the C double bond C is attached, and you're going to you can counting can be done from either end. There's no rule in counting, so counting is done from either end, but that end is picked where you get a smaller number. The position is smaller. So counting is done from the end which gives a smaller counting is done from the end which gives a smaller number. So in this case, if you look at the two carbon atoms, if I start counting from this side, then this is 1. Let me correct this. So this is 1. This carbon atom is 2. This carbon atom is 3. And this carbon atom is 4. So if I count from this end, then the double bond position and the nearest carbon atom on which the double bond is located, it is at position number 2. Vice versa, let me clear this. If I count from the other end, then this would be carbon number 1, this would be carbon number 2, and this would be carbon number 3, and this would be carbon number 4. So if I'm counting from the left hand side, then these are the numbers that I'll get. So from either end, in this particular case, the double bond is located on carbon number 2, which is the smallest number. So the molecule, if I want to name it correctly, I would have to write down the position of the double bond. So the actual name of the molecule, so between the prefix and the suffix would be the position of the double bond. So it's Butane in this case, where 2 indicates the position of carbon double bond carbon. That's the additional thing that has to be taken care of when you're naming alkenes. So let's do a few more examples for alkenes, and let's try and draw another alkene. We have let's say we have five carbon atoms, and there's a double bond attached at the very first one. So we have this alkene, and let's draw the rest of the atoms are hydrogen. So we have 2 hydrogens over here. There would be 1 hydrogen over here to complete the bond. This needs 2 more bonds, so there would be 2 hydrogens over here, 2 hydrogens on this side, and there would be 3 hydrogens over here. So let's say we have this molecule, and we're going to try and name this molecule. It has a total of 5 carbon atoms, which means that the name is going to start off with pent. So 5 carbon atoms, it means the name starts off with pent. And since it's an alkene, so the name is going to end with ene. So this indicates that it's an alkene. And we just need to figure out what is the position of the double bond. So if I count from the left hand side, the double bond is on the first carbon atom, and counting is supposed to be done from the side which gives you the smaller number. So from this side, if counting is done from this side, I get that this is carbon number 1. On the other hand, if counting is done from the opposite side, then this is carbon number 1, 2, 3 and 4. So from the right hand side, I'm getting that the double bond is at carbon number 4, whereas from the left hand side, I'm getting that the double bond is at carbon number 1. And we always choose the smaller number. So we're going to count from this side. This is the correct side to count this molecule, to do the counting. So it's pent 1-ene. So the name of the molecule is pent 1-ene, and let me underline this. So this is how you name an alkene. Let's do another example. Let's take another molecule. For example, we have six, the 3, 4, 5, and 6 carbon atoms in a line, and there is a double bond over here between these two carbon atoms. And let's draw all the hydrogen atoms. This is going to have 3 hydrogen atoms attached to it. This has 2. This only has 1 hydrogen, whereas this also has 1 hydrogen, and this has 2 hydrogen atoms, and there are a total of 3 hydrogen atoms attached to this. So let's try and name this molecule. This molecule has, the first thing is you figure out what the prefix is going to be. So the first thing is it has 6 carbon atoms, which would indicate that the name should start off with hex. And it's an alkene, so the name should end with ene. So it's an alkene because it has this carbon double bond carbon in it. And lastly, what you need to do is you need to figure out the position of the carbon double bond carbon. So if I count from this side, the left hand side, this is carbon number 1, this comes out to be carbon number 2, and the double bond is located at carbon number 3. If I count from the other side, this is carbon number 1, this is carbon number 2, and this is going to be carbon number 3. So if I count from the right hand side or from the left hand side, in both cases the double bond is located at carbon number 3. So it doesn't matter in this case which side you're counting from. So in this particular case, it really doesn't matter. It's always going to be hex 3-ene, whether you count from the right or from the left hand side. So the name of the molecule is hex 3-ene.